So hopefully you've already gone through this program, either watched the previous video or looked at the slides and stepped through and seen what the program's doing allocating local variables. What I want to do in this one is actually step through it here in PEP8 so we can actually take a look at where memory is and how memory gets assigned and all that. So I'm going to go ahead and start the debugging and step through this. So we start with our normal branch. So we branch down to main. Now notice we jump right over our equates. Remember, our equates are up here to say where variables are going to be stored on the stack. Well, the first one is the constant, so that one actually gives it a value, but the other three that are variables are giving it locations on the stack. So where is the stack? Well, if we look here at our stack pointer, we see that the stack is at address FBCF. So if we come over here on the right hand side, there's actually a little button down here. We can actually hit SP, and that actually takes us down to that region in memory. So now we're way down in low memory, or high memory, down towards the bottom, but in high memory at FBCF. That's where our stack is. So at this point, if we had anything on the stack, or we could even think about it as basically everything down below here is what's on our stack. But we haven't put anything there, so there's nothing there. So what we're going to do with this sub SP6 here, remember we're subtracting 6 from the stack pointer, so that's going to take this FBCF and subtract 6. So I hit the single step, and I've now subtracted 6 from that space. So now essentially what I've done is, as far as the program's concerned, I've allocated these 6 bytes to the stack. And if we look at the equates back up here, the way the equates are written, I have score as equate 0, so that means it expects that score is going to be stored at offset 0, so it'll take up those 2 bytes. Exam2 is at 2, so if that's 0 and that's 1, then that would be 2, so that would be where exam 2 is going to be stored, and then the next one, that would be where exam 3 is going to be stored. So again, that's what the equates are doing. They're showing you where on the stack the variables are going to be. So when I do this next command here, this decimal input exam1s, so I'm saying I want to input a decimal. I don't want to input it to exam1, and I'm using address mode S, so that means it's going to look at the stack, and it's going to look at exam 1 and see that it has an equate 4, so it's going to go to the stack, and then it's going to go over 4 bytes, so 0, 1, 2, 3, 4. So when I step through this, it's prompting me, and I'm going to type in a number here and say 85 and hit enter, and my value just went on the stack. So now that variable I just entered has been entered on the stack at offset 4. Remember that 85 gets converted into hexadecimal, so 55 is the hexadecimal equivalent. So now I'm going to do my second one, my exam 2. I'm going to step through that, and I'm going to put in another grade. I'll put in a 90. So exam 2 is stored at equate 2. So if my stack starts 0, there's 0, 1. So this one should go right there. And if I hit enter, it does. So there's my next score went in there. So that's the idea, is that when you're using stack variables, it's unlike the global variables. Global variables, we put an address of 0 and it was always at 0. Here with the stack, because it's local, and if you think about it in terms of C++ functions, you can call a function from anywhere, so that potentially this stack could have any value in here. So we can't just give it a straight address. We have to say, okay, well, we start at the stack, and then we use the equate to figure out how far to go to see what we have available. So now I load the first value into the accumulator. I add the second one in there, and again, this is that same program we used before. So I've loaded the first one in, I added the second one. I'm going to shift right so I can do a divide by 2. So all this is getting done up here in the accumulator. Divide by 2. I add my bonus in there. And remember, that was a constant, so I used the I immediate for that. So I've got an 87 in there now. I step through, I add 5, so it's a 92. And now I'm going to store it back to my score variable with using S So I'm using my stack offset. So again, I look at my score. That's at equate 0. So I look at my stack, which is FBC9, which it's already highlighted. So offset 0. So my score when I store it is going to go right there. So there, my score has been stored on the stack. And now I go ahead and the rest of it again the same. I've left the string, the message, as essentially a global variable. You can make these locals too, but think about it. If you made it local, you'd have to count up every one of these bytes and calculate and figure out where it goes on the stack and what the offset is. It's just not worth it for us. I mean, it actually goes back to why using strings in C++ and actually any language is relatively inefficient, because there's a fair amount of manipulation that goes on, and we're just going to avoid that problem with PEP 8. Feel free to do it if you like, but any of the examples I do, anything I go through, I'm going to keep the ASCII strings as being globals and just worry about using the characters and integers and things as locals. So anyway, since it is down here as a global, when I access my string, I got to use my D again, so for my addressing mode. So that one does come out of the same place all the time. So I get my score output, back to getting the score off the stack, so that's an S. Character output right inside the message for my new line, so that's immediate. And then finally, since I'm all done with my variables, I've got to give space back to the stack. So essentially I'm going to add 6 back, so I'm going to move my stack pointer from here back to where it was originally. So it really is just the opposite of I allocated sub SP6, so when I'm done, I'm deallocating with add SP6. So I subtracted to move it this way, and I'm adding to move it back that way. And something to keep in mind here, I did it. I added so that the stack pointer is back to its original FBCF, so it's back over here. It didn't change any of these variables, or it didn't move any of this memory space. The memory is still there. It doesn't clear anything out. You could, and if you're potentially writing a secure program, you'd probably want to. But in most cases, whatever was on the stack stays on the stack, or stays in that memory on the stack. It's just that as far as your program's concerned, that's not the stack anymore. Your stack starts here. So, and then we finish up a program with a stop. So we're done again. And I'm going to I'm not going to do it now. I'm going to come back and run through this again to talk about the traces down here. But we'll come back to that for video number 3.